Hello everyone, today in this video we'll be discussing the 8th lab program, which is the bankers algorithm. So in this program we have the process allocation and the resources management to avoid deadlocks. Okay, what is a deadlock? A deadlock means you will be having means a resource wants to go in this direction and another resource wants to go in this direction and here and here. Okay, so this is a deadlock because each of them is waiting for the other one to move first, so that is known as deadlock. The same thing goes for process as well. Two process wants one thing, and that this thing is owned by this one, and another thing is owned by this one, but this thing wants this one and he wants this one. Okay, so like that it's a deadlock. So to avoid the deadlock, there is some technique which is the bankers algorithm, which we'll be discussing. Okay, so this video is divided into two parts. The first half I'll be discussing about the algorithm, how it works, because if you understand the algorithm it will be very easy for you to remember the code, because in algorithms there will be a few steps, means in the means what problem I will be solving, there will be few steps. Follow means if you remember those steps, you will be knowing to write what code here, in what code here, and next what you have to write. But if you directly try to memorize, everything will look same to you. All the arrays and the variables will not know why they are why we have taken those arrays. You got the point, right? So I am discussing the first this part, and then I will be discussing the code, and I will be connecting the code and this part in the second half, so that you will be able to synchronize between both. Okay, so if you like this video, hit the like button and don't forget to subscribe to my channel, and let's get started. Firstly, I'll be showing you the code if I have here. So bankers algorithm is here. So this is the code. If I give you the overview of what this code is, just like any other code, here we have the declaration function, and then we have the void main function. Okay, in the void main function, first we have declared some things here. As you can observe, we have declared some things here, and then we'll be filling these things. Means these are the empty arrays, right? For example, allocation array, maximum array, need array, available array, and finish array. So this has to be filled with some values. So that's what we are doing in the next part. We are taking the number of process here, number of resources, the allocation for each process, how much should be allocated for each process that we are taking, and each of these values we are trying to allocate here. Means for each process what is the values, maximum claim for each process. These are the input values we need to have before beginning with this program. And the next one is total number of each resource. After we have taken these things, then we will be starting the original program from here. One for loop is here and another for loop is here, and the available resources are, it is showing as this, and then we have a few more for loops here, and then we have the while loop. Okay, in the while loop also we'll be doing the same thing. We'll be iterating to the arrays and calculating the values. Okay, so that is somewhat some of the things which we need to keep in mind in the program. So since it's a long program and it won't make any sense for you if you just try to memorize it directly, it will be very hard, and it's means many chances are there you might make mistakes in the writing the name of the array or the for loop. So it's very important to understand the algorithm first, so we'll be doing that now. Okay, so let's move back to the problem sheet. So let me explain you what is the whole problem about. The whole problem is about, like, you have some three resources. Okay, let's call three resources A, B, C. Let's put some names: A for apple, B for ball, and C for what? Cat, right? So some apples are there, some balls are there, and some cats are there. Okay, and how many processes are there? Those are your friends. So 5 friends are there along with you. Okay, including you, 4 more friends are there. So total 5 people are there, and the means the things are apple, ball, and some cats are there. Okay, so each of them wants some balls, some wants apples, some wants cats, some wants both, and some wants all three. So those things are there, and what we have to do is we have to find out a way in such a way that if one has means 5 apples, the another one should not ask for the apples at the same time. So we have to make a sequence in such a way that they should not fight for the resources what we have in the system. Okay, means that's what basically at the bottom line what we are doing is we are trying to allocate resources to the process in such a way that after one process finishes the means whatever it has to do using the resources, then it will be using the next resources. Okay, so that is synchronized for all the process. So that's what we will be doing in the program as well for each of these process. Okay, so here as you can see there are 4 columns, allocation, maximum need, available, and remaining need. Okay, so before starting we have been given with this information, like a is 10 means whenever I say a, think of apples. Okay, we have 10 apples with us, and there are b is 5 means we have 5 balls, and c is 7 means we have 7 cats. Okay, so these are the things which are available with us. Okay, so these are the resources available with us. A is 10 and b is 5 and c is 7. Okay, now let's see what do these columns denote. The columns denote allocation. Allocation means already how many things are given. Okay, how many apples are given, how many balls are given, and how many cats are given for process 1. Okay, for your first friend, one ball is given to him. Okay, for your friend, one ball is given. That's what it denotes, and 0 apples and 0 cats is given. And the second column is maximum need. What is your friend's maximum need? Means how many balls he wants, how many apples he wants, and how many cats he wants. That is written here. Okay, this is the information which is given to us before starting this algorithm. So we need this information to process further. Okay, that's the same thing given for process 2 as well. He has been given with 2 apples and 0 balls and 0 cats, and he wants at means totally he wants 3 apples, 2 balls and 2 cats. Same goes for process 3, process 4 and process 5. Okay, so we have allocated these things. Total we had 10 apples, so we had allocated this many apples to different friends. So how many apples are over? 7 apples are over. Same thing goes for B also. This many balls are allocated, so 2 balls are allocated, that's over. 5 cats are allocated and 5 cats are over. So how many are remaining with us? Among 10 we have allocated 7, so remaining is 3. From 5 we have allocated 2, remaining is 3. From 7 we have allocated 5, so remaining is 2. So this is what we have been means this many apple, ball and cat we have as of now after the allocation. Okay, this is what you need to keep in mind. 332. Okay, so where we will be writing 332? We will be writing here available. How much is available at that point of time? That will be writing here. So how much is the 332, right? So 332. Now we have written how much resources are available with us, right? So what's the fourth column? Let's see that. The fourth column is remaining need. Remaining need means the maximum need is this much. This much have been allocated. So what is the remaining need of the first friend? So he needs 7 apples, 5 balls and 3 cats, but he has been given with 0 apples, 1 balls and 0 cats. So the remaining need will be 7 minus 0, that will be written here. 5 minus 1 will be written here. 3 minus 0 will be written here. That's the remaining need of the first person, right? So it will be what? 7 and 5 minus 1 4 and 3 minus 0 is 3. So this is the remaining need of first friend. Now what we have to check is, before filling the rest of the columns we need to perform this iteratively. Okay, so what we are trying to see is, can the need of the first friend be satisfied with the available resources? Yes or no? That we are trying to find out. Okay, so the need of first person can be satisfied with the available resources. You tell me. For this it cannot be satisfied, this also cannot be satisfied, and this also cannot be satisfied. Even if these two can be satisfied and one of them can be satisfied, still we won't consider that. All of the needs should be able to be satisfied with the available resources, then only we will consider that process, because then only that makes sense, right? Because if one resource is not available, that person will fight for one resource and again deadlock will happen. So we'll just select that process for which all of the available means how much we have, all the 3 categories can satisfy all the 3 categories need of the first person, then only we will consider that person's need first. Okay, if for all the process it cannot satisfy, if we check no like that till the person 5, then we will declare it as it's not possible to satisfy any of the person's needs. Okay, that's all. So let's see for the first one. It's not available means we cannot satisfy the first person's needs, so we'll move on to the next one. Next one also we'll write the same thing. How many available resources are there? The same, 332. And now we'll see what is the remaining need. Remaining need is, this is the maximum need, this is the allocated one. So 3 minus 2, 2 minus 0, 2 minus 0, which is 122, right? So let's write it as 122. This is the remaining need of the first person. Now we have to see if this need can be satisfied with the available resources or not. This can be satisfied, this also can be satisfied, this also can be satisfied. So what we are going to say is, with the available resources, this process can be, means its needs can be satisfied, so we will select that process and give these resources to this person, and he will take those resources. He'll take these resources, use those resources, and release these resources. These three things will happen. He will allocate these resources, he will use those resources for his use, and after some time he will give back the whatever resources he had and how much he had taken. The total resources owned by him at that particular point of time, that will be returned to us. So let's take it step by step, one by one, what's happening. Okay, now we have given these resources, okay, for him. Okay, friend 2 is happy now, he is using those resources, so let's write his name, friend 2, which is P2, right? P2 has been selected first for the satisfaction of the need. Okay, so after he has taken the resources, used the resources and everything, he will release these resources after he has been satisfied, right? So how many resources he had? 2, 0 and 0. Initially he had this much, we have given him this much. So after he uses the total resources and releases, how many resources we will have is adding this one with the how much we gave. That will be the available resources as of now. Because his need is over, he need not use these resources again, he will release this, and so we can add these resources to the existing resources which we had. So what will be the total number of resources is, add these two resources, 332 plus 200, that what we will get answer as, we'll get the answer as 5, right? Because 2 was with him and then we had 332, so he released 2 resources, so we have now 532 available with us, and process 2 is over. So what is over, we will mark it as red mark. Okay, so let's move on. What we have is 532, so let's write it down here, 532, and we will see how many available resources are, means remaining need of this friend 3. So our friend 3 needs how many more resources? 902 minus 302 means 600. He needs 600 resources to satisfy himself. Okay, 600. Okay, so is it available for us to satisfy his needs with the available resources? No, because we have 5, he needs 6. Because of this one, we cannot satisfy him, right? So we will not consider him. Okay, then we'll move on to the next one. In the next one, what we have, the same number of resources, available resources, which is 532, and what is the remaining need of this person? 422 minus 211, which is 211, right? 211 will be writing here, 211. Now can our available resources satisfy his need? Yes, his need can be satisfied with the available resources, right? So what we'll be doing is, we'll be updating the resources which are available with us. Okay, so let's update the available resources. So how much means these resources will give him, he'll use these resources and release the resources which which he had initially. So we'll add this with the existing resources. So 5 plus 2 will be writing here first, which is 7, and next we have 3 plus 1, which is 4. So let's write it here as 4, and 2 plus 1 is 3, so let's write it here 3. So these are the available resources with us, and we'll be moving on to the further stage. Now in the further stage, P4 is also done, right? So we have to write P4's name in our list. So this is the second person who got his need satisfied, so P4, and let's move on. We'll check for P5. So what is the remaining need of P5? Maximum need minus the allocated resources. So 533 minus 002 is 531, right? 531, let's write it, 531. And how much the available resources? 743. Can we satisfy his need? Yes, we can satisfy, right? So let's cut P5 as well, so and move on further. So let P5's name here, third person whose need was satisfied, and after that we'll come back, and his how many resources he had, that he has released. So 002 is released, and we'll be adding with the existing one. So how much we had is 743 plus 002 is 745, right? This is the available resources with us as of now. After this has been done, we have to move back again. Okay, move back again and check what are the resources left again in the starting order. So P1 is left. Now how many resources we have? 7, 4 and 5, so we got to update this one. Available resources 7, 4, 5. Okay, so we'll write here 7, 4 and 5. 7, 4 and 5 is written, and let's see what is the remaining need of process 1. 7, 4, 3. This can be satisfied with 7, 4, 5, and that will be done, and this will be released. After this is released, what is the available resources with us? We'll be adding this resource, so it will become 7, 5 and 5, right? And P1's name also will be written after putting the red mark. Okay, so P1 will be the fourth person whose need was satisfied. Now let's see if the last person's need can be satisfied or not, which is P3. So how many resources are available with us? 755. So let's come to P3 and we'll write here 755, and let's see what is the need of P3, 600. It can be satisfied. So after using that, it will release these resources 302. Let's add it up, so it will be 10, 5 and 7, right? So 10, 5 and 7 will be written here. Okay, so let's write it 10, 5 and 7, and P3 will also be having his name written in the list. So P3 will be the fifth person whose need was satisfied. Okay, so this is the allocation order. If you follow this order, then deadlock will not happen, no fight will happen among all your friends, everyone will be happy, and all the resources will be finally. How many resources we'll have? We'll have the same number of resources how many we gave initially, right? We had 10, 5 and 7 initially. After he used the resource and released it, all the resources are back with us, 10, 5 and 7, right? So these were the initial resources with us, 10, 5 and 7. Okay, so this is the order which will be printing in the output part. This will be printed along with this table. This table will also be printed. So the things which you need to keep in mind, observe that carefully. What is the things you are going to take in this program? Okay, so let's come to the code part, and this part means alternatively, and discuss means how is the code part related to this one. Okay, so observe carefully in this code what we have. In this code we have these so let's take red. It will be both visible in black and white. So yeah, let's get started. We have included the stdio.h, and after that what we have is allocation matrix, maximum matrix, which is maximum need, remaining need, available, and finish. Okay, these are the things which we have taken the arrays. Now let's understand for what we have taken each of these arrays. Allocation you understood, maximum need also, and remaining need, available. What is finish for? Finish array we'll be discussing later. As we go through the program, we'll understand why we have taken finish array. Okay, for now let's just keep in mind. Okay, then we have two more resources, which is rsrc and safe. So let's see the end of the program. Here I think we are outputting the safe sequence. So since you are outputting the safe sequence, what we have is in the safe array the final output will be there. In the safe array, what final output will be there, like we have written at P1, sorry, it was P2, P4, P5 I guess, and P1, P3. So this is the sequence which will be writing in the safe array. Okay, so that's what the safe array is for. And let's see what are the different arrays for. Along with that, we have int P, int R. P is the number of process, R is the number of resources, count is 0, I, J, total, loop C, and K. And we have the first for loop, which is I is equal to 1 till 7, I plus plus. We are taking finish of I as 0. So here we have finish of I array, that will be initialized all as zeros. Okay, all zeros, it will be initialized first. Okay, and then we are taking enter the number of process. We are taking how many processes are there. In our example, how many processes were there? 5 processes, right? These were the 5 processes which we had, and so the number of processes will be 5. P will be equal to 5. Okay, so P will be equal to 5, and enter the number of resources. How many resources we had? A, B and C. So R will be equal to 3. That will be storing. And enter the allocation for each process. Allocation for each process is the first column matrix. Okay, this one I'm talking about. We are trying to get this information. Okay, enter the allocation for each resource. This information we are taking by using a for loop. First for this one, then for this one, and so on. Okay, observe carefully what we are doing for taking each allocation of the process. I is running from 1 to P. P is the number of process, right? So we had how many process? 5 process. So for each process I will run 5 times it will run, and what it will take for process 1, j is equal to 1 till r. Why is it running from 1 till r? Because for each process there will be 3 resources, a, b and c. So we need the value for a, b and c each iteration. So in the first iteration a, b and c for the process 1, then I will become 2, it will run for this one, then this one, this one and this one. So like that it will take the values. Okay, and that will be stored where? In the allocation array. Okay, that's the first for loop. And the second for loop is the max claim. Okay, so if you see this part here, here we have the maximum need, right? Maximum need also will be taken in the similar way, and yeah, this is the maximum need will be taking for each process. The maximum need for means process a, b and c, for each each process maximum resource need that will be taking. Okay, that will be done in this one. This is also a double for loop, I is equal to 1 till p, j is equal to 1 till r. Okay, this is done. And then we have enter the total number of each resource, means we are taking how much a is there, how much b is there, how much c is there. Before we are just input r is equal to 3 means how many resources are there, which is a, b, c. Now we are trying to find out how many a is there, how many b is there and how many c is there. That we will be taking here. J will run from 1 till r. Each time it will take the maximum number of resources in each a, b and c. That's what rsrc is used. The resources, how many resources are there in each one. So an array is there here which is size 3, a, b and c. How much are there? 10, 5 and 7. That will be stored. Okay, that's what rsrc is for. Then we have the next for loop for j is equal to 1 till r. It will run from 1 till 3, 1 to 3 it will run, and it will allocate total is equal to 0, available of j is equal to 0, and we have a second for loop here. Okay, in the second for loop what we are doing, I is equal to 1 till p, total plus is equal to allocation of I and j. Total plus is equal to allocation of I and j. So what will total become? How much we have allocated. Okay, it will run for each of these process for means how it is running, you know. Here we have the j loop which is running from 1, 2 and 3. Okay, and we have 5 process here, 1, 2, 3, 4 and 5. 5 processes are there, and what it does is it will run for each process. So first it will come here, then it will add the allocation of value. Allocation value means the first column, that will get added to total, then this will be added, this will be added, this will be added and this will be added. So a, how many resources are allocated, that will be added and stored in total. Along with that, what we are doing, available is equal to rsrc of j. rsrc means, remember we have stored in rsrc the maximum value of a. How many resources are there in a? 10. That we had stored in rsrc in the just the previous loop, right? So this will be subtracting with the total. Total means this one total minus what it comes as total 7, right? So 7 and 10, this will be subtracted and stored in available of j. So why is available array used? How much is available with us? That's the second column, right? Means I mean the third column. First column is what? If I show you again, here as you can see, the first column is the allocation column, right? Second column is max need, third column is available column. In available column we will be subtracting the how much is totally allocated minus how much was total with us, which is 10, and here we have the total sum as 7. 10 minus 7, that is written in available. Means initially you remember we had written 332, that's what for a, b and c. Okay, that's what's happening in the next code, means which code we are discussing right now. Okay, so that's what's happening here. Yeah, here this code is for that purpose, for filling the available how much is available with us. Each process a, b and c, how much is available, the first column value we are storing under the column available, how much is a available, how much is b available and how much is c available, after allocating all the resources to all the process. Okay, that's what this loop is for. Moving on, we have the next loop. I is running from 1 till p. P is the number of process, so I will run 1, 2, 3, 4 and 5. So I will run this much, and here we have another for loop which is j till r. Means for each process, let's write the process as in this way, 1, 2, 3, 4 and 5, and a, b and c. For each process it will run. Need of ij is equal to max of ij minus allocation of ij. Means the remaining need of each process, remaining need here, remaining need here, remaining need here. For the process 1, what is the remaining need of a, what is the remaining need b, what is the remaining need c. That we will calculate by what is the maximum satisfaction need of that process for each resource minus how much that resource was allocated to him. For example, here it was 10, means he need 10 apples to be satisfied, and he was given with just 5 apples. So what is the remaining need for getting satisfied? 10 minus 5, which is 5, right? So that will be stored here. In the same way, for the next one it will be stored here and it will be stored here. Then we will move on to the next process when I will become 2. Like that I will go from 2, then 3, 4 and 5, and these things will be stored. What we are storing, this which column we are storing? The need column. Okay, remaining need column. If I show you in the problem, here we have the remaining need column, right? The fourth column that we are storing. What is the remaining need for each of these process, that will be storing here. So iteratively we are doing, right? If you observe carefully, what we are doing is we are doing it iteratively. First we have filled this one, then we are filling this one, then we are filling this one, then we have filled this one now. So as of now we have filled these things. Now let's see what is the next step. Okay, next step is available resources are for j is equal to 1 till r. Okay, j will run from 1 till r, means it will run from 1, 2 and 3. So let's write it as such, 1, 2 and 3, and print f percentage d available of j. So what it will output is, in the output part, this is the output part. Okay, in the output part it will output percentage d available of j. In available of j, what was mentioned is 332. In the first case it is 332, because that's what the available resources after allocating the resources, right? From the total what we had allocated some resources, we allocated some resources, and this is the available thing. So this will be the output first in the screen. Okay, then what we have, printf allocation matrix, maximum matrix, need matrix. Three things we are outputting: allocation matrix, maximum matrix and need matrix. This line will be printed. Okay, next what we have is the for loop. Okay, in the for loop, how many times it's running? From 1 till p, means 5 times it will run. And what it will do, running 5 times, we have a for loop here. Okay, it will run 3 times. Let's see what's happening. Allocation of ij is getting printed. So allocation of ij for this process is getting printed, and yeah, then what will happen, will come out of this and we'll have percentage t. So after leaving some space, again for each of these process 3 values will be printed. For this one, maximum also it will be printed. Then for the remaining need, for the means available resources, so these 3 things it will print. Okay, maximum need, need matrix and allocation. For these 3 things it will print the first column, first row, then it will print the second row, then it will print the third row, it will print the fourth row, and it will print the fifth row. That's what this outer for loop does, and the inner for loop prints the each of these individual things: allocation matrix, maximum matrix and need matrix. Okay, that's what it does. Means it's just outputting the current situation. Okay, what are the values we have obtained, that will be the output. Okay, now let's come to the while part here. This is the while loop. So let's see how much is the while loop running from. While loop has started here, and okay, basically that's it. Means the while loop will run from here till here. Okay, means if we finish the while loop, then it will be over. Okay, so are we under any loop here? I guess not, because 1 2 3 4 3 4 3 2 1 0. Yeah, so the while loop will be running till here. Okay, just we are left with one while loop, and the criteria for our output is, if count is equal to p, it's in the safe sequence, then we will output the safe sequence using the safe array which will be storing, and else it's in the unsafe state. So we just need one while loop to run and we are done. Okay, if count is p, our criteria is c should be equal to p, then it's in the safe state. If it's not, then it's in the unsafe state. Will print like that. Okay, so let's see if it's in the safe state or not. This is the main part of the program. Till now we have just initialized the things, initialized how much is available and those things. Now we are trying to see how many can be allocated, can its need be satisfied, and if it releases the resources, we have to add the remaining resources again to the program. So those things will be looking now. Okay, so observe carefully the while loop. While loop c is less than p. So remember, initially we have taken the loop c as 1. So is 1 less than 5? Yes. So till all the number of processes is there, we will run the program. Till 5 it will run, means 5 times it will run. Okay, and count is not equal to p. What is the count value we had taken here? Count is initially 0. Count is not equal to p, means is 0 equal to 5? No, 0 is not equal to 5, right? So it will run till the number of processes is there. Okay, and firstly we will be doing plus plus loop c, because we are doing the first iteration, one process should get selected, so loop c will be incremented. Okay, and here we have first the for loop, and this for loop runs from here I is equal to 1 till p. So okay, let's take it 5 times it will run. Okay, because we know the number of processes are 5, and here we have the condition if finish of I is equal to 0. What is finish of I? Initially we have taken it as 0, so obviously we will come here and take it as means it will come inside this if condition, and here we have the for loop I is equal to 1 till r. So for each of this line it will run. If need of I is greater than available of j, what is the need of I? Means the remaining need, if it's greater than the available how much is there, then break. If the need is greater than available, if the remaining need is more than what we have to offer him, okay, for example his remaining need is 10 but we just have 5 available with us, so at that time we have to what we have to do is break out of what, this for loop. Okay, if we break out of this for loop, where will we reach? Okay, this for loop is starting from here and ending here. Okay, right, this is the for loop. So what it is trying to test is if we do not break out of this, at that time what will happen, we'll come to this part, right? How will we know if we come to this part or not? We'll see later. But now what will happen, since one of the resources is not available to satisfy its need, means a b c is there, right? If any of the resources is greater, the remaining need of one of the resources is greater than the available how much we have. Okay, if the need is more than the availability, at that time we'll break out of this loop. Okay, so in the first case we'll break out of this loop and come here and we'll check if j is equal to r plus 1. How will we know if j is equal to r plus 1 or not? What was r? R was equal to 3, r plus 1 is equal to 4, right? So when will this condition become true? This condition will only become true when this loop will run for 3 times, and in the 4th time when j will become 4, it will come out of this loop. So this condition is just checking that if all of the ABC's needs are less than the availability, right, then only it will run 4 times, means j's value will become 4 and this will be satisfied, right? If it comes out before that, that means the need is more than the availability, we should not consider this part. That's all what it's checking. So there are two situations, either the need will be less and it can be taken, or the need will be more and it cannot be taken. So that's what the check is happening here. In case if it is less and it will not be taken, it will move on. It will move on where? To the next process. How it will move on to the next process? We are under this loop. Okay, in this loop i's value will become 2, so process 1 cannot be taken now, we will not do anything, we'll come to the second part. That's what we did in the code as well, right? If you remember, we had iteratively cancelled the process which we are taking, right? If we cannot take p1, we had not cancelled p1 in the first iteration, it was not able to satisfy the need initially, so we moved on to the second process. That's the same thing we are doing here. Whichever need can be satisfied, that will take first. Now let's see a situation where the need can be satisfied. Since in p1 it cannot be satisfied, we ignored this part here. Now suppose that it satisfied means for how much need is there, that is less than the availability. Okay, so it can be satisfied, so this will become true and will come in this part. In this part, let's observe what is there. In this part, j is running from 1 till r. So this is the j abc, it's running from 1 till r, and what we are doing is just one line of code, availability of j plus is equal to allocation of ij. Since its need can be satisfied, we'll give him the resources, he will use the resources, and whatever he had, okay, see, this is what we had and this is what he needed, okay, and he had some things initially, so we gave all these resources along with how much he needed. Since we had more, we gave him, he used these resources for each a, b and c. He used some of the, means he had some, and we gave him some, so he used these 3. Now after using these 3, he has to release this one and this one, and when he releases this one, we'll add it up with the a part in here. When he releases this one, we'll add in b part of this one. When he releases this one, we'll add in c part of this one. So that's all what we'll be doing here also. Okay, available of j plus is equal to allocation of ij. How much was allocated? Plus is equal to available of j. Then j will move on here, allocated of j plus is equal to available of j. Allocated of j, j will move here, available of j plus is equal to allocated of j, so it will get added up here. So whatever he had, that will be released and that will be added up to the available resources. Okay, So that is what happening in this line of code. And after that we have finish of I is equal to 1. Why we are taking finish of I is equal to 1? What does I denote? I denotes the process number, right? I denotes the process number. So I is equal to 2 initially, means I was 1, it was not satisfied, so it was 0 only in the finish array, and I is 2 now. So when 2 is there, it turned 0 to 1. So what does this denote is, we should not repeatedly come to the same process and satisfy his need. Once it's satisfied, it's over. We'll remove this from the array, right? That's what we did. Once we have satisfied someone's need, at that time what we will do, we'll remove him from the list, right? Means we'll mark it as removed and write his name in the list. So removing from the this list and writing his name in the another list. Okay, so that's what we are doing. So if we mark finish of I as 1, next time this will not be executed, right? That condition was being checked here. If finish of I is 0, then only will come under this loop, right? If finish of I is 0, then only will come under this loop. So this makes sure that whatever process we are considering, that has not been considered before, or it has failed before, right? If it has passed and satisfied its need before, we'll ignore that. For that, this check is made. Okay, now we understood why finish of I is used, right? Okay, so finish of I will be made as 1 plus plus count. Why we are doing plus plus count? Because one resource is taken into the consideration, so we have to increment the count. So count will be from 1 till 5. So when that will be over, it will come out of the while loop. For that we need plus plus count. Okay, then we have save of k plus plus is equal to I. We have removed him from one list, written in another list. Removing one list was done here, writing in another list is done here. Save of k plus plus is equal to I. In k value it will be written I value, which is 2. So first 2 will be written and k will be incremented and pointed here. Next whatever happens again, means which process gets selected, his name will be written here, means that I number, then it will increment here. Like that the save sequence denotes means saves the list of the order of or the sequence in which the process are executed. Okay, that will be stored here. That's what happens in save of k. And after this happens, again we'll move on to the third process. I will increment and we'll come to this part here. Okay, I will increment and will come to this part here. And after this happens, again we'll check if it's possible to satisfy its need. If it's able to satisfy, we'll come here and remove him from one list, write in another list, and repeat the process. Now this happens until we finish this line of code, which is I is equal to p. Once it's over, it's possible that some of the process in the first iteration might not get selected. So what we will do, again we'll come back to this loop here, plus plus loop c. Okay, plus plus loop c will increment the loop count, right? So that should be less than the number of total process. So the maximum number of iterations will be what? Once it is coming here, second time, third time, fourth time, and 5 processes are there, maximum it will come to 5 processes. Each process, even if one gets selected, it will come. But what if one of the process never gets selected? If in that case it never gets selected, at that time loop c will become greater than p and it will come out of the while loop, right? And one process is not selected, so we'll be making a check here. Count will be equal to p, it will not be equal to p because one process was left, so it was not equal to 5. Count was keeping count of how many processes are selected. If it's not equal to p, means one of the processes is not selected. That means it will not come in this loop. That means it will not be showing this output as save sequence. Instead it will show as unsafe sequence. Okay, that's all what is there in this program. Okay, so let's quickly revise from the top till bottom what we have discussed from starting from the algorithm. So this video was a quite long video because understanding the algorithm is very much important to write the code part, or there will be many mistakes, right? So let's start from here. What we'll be given with is the number of apples, the number of balls, and the number of cats, and how many people are there, how many friends you have. All your friends names will be written and we'll make 4 columns. Allocation, how many things are given to your friends already, how much things your friends need, and how much is available with us to give to them, and what is their remaining need. These 4 things will be filling iteratively. First we'll fill this one, then we'll fill this one, and then only this we will fill, and remaining needs will fill together. Okay, and we'll be checking if it can be satisfied or not. If yes, we'll take its name in the list, else we'll move to the next one and if it is yes, we'll take, else we'll ignore and move to the next one, and like that we'll keep on doing iteratively. The number of process, how many are there, that many times we'll iterate. If in that many iteration all the process are coming, it's okay. If it's not, it's not. Okay, so let's go through the code once. So see here in the code, first we have taken hash include stdio.h. We have did the declaration parts, allocation, maximum need, and the remaining need, available need, and the finish. Finish is just for removing from the first list. Okay, we are just checking if it's finished or not, that process. Okay, rsrc, the number of resources, how much is there in A, how much is there in B, how much is there in C, that we are storing. And safe means what is the safe sequence, the final output that sequence will be storing in safe array. And for P is the number of process, R is the number of resources. In our case, P is 5 because 5 friends are there, resources is 3, we have apples, balls, and cats. Count is 0, count is just checking for if the how many we have selected the process, that's equal to the total number of process finally or not. I and J is just the temporary variables. Total is used for how much total allocated resources are there in each part, A, B, and C. Okay, and loop C is just for counting if in each iteration it is getting selected or not. The maximum number is, it can be 5 only. Loop count, K is 0, K is just for keeping count of the sequence. Okay, means the safe sequence, the index value it will be storing. Okay, and how many for loops we have, count. Okay, here we have the first for loop, which is for initializing finish of I0. Second for loop, sorry, we are taking the number of process, number of resources here. So P and R will be taken as 5 and 3 here. Allocation for each process, allocation will take a for loop, double for loop, because it's allocation means for each process, each resource we need a 2D matrix, right? So this is the second for loop. Inside that we have in the for loop. Okay, and third for loop, again max claim, double matrix. So we have a third for loop here. And the fourth for loop, enter the total number of each resource. So it's just the number, which is A, B, C. 3 times it will run and it will store 10, 5, and 7. And here we have the I guess fourth or fifth for loop. Okay, so it doesn't matter, let's take it as fourth for loop. Here we have J is equal to 1 till R. And what we are doing here, remember this, for what are the first column, allocation column, right? For the allocation column we are doing this one, as well as available column. Okay, third column we are filling this one and this one. Then we are filling the remaining need column, because maximum need is already taken in the array, means the previous lines of code, and the remaining need is taken here. So 5 or 6 for loop here. And available resource, it will just output how much is the available resource, and here starts the printing process. So 6 for loop, and here we have 7, 8, 9, 9 for loop for, and it's another inside another for loop. So we'll have total 3 times it will print for each row, it will print like this, it will print for each number of process. The outer loop is for keeping the count of process, here for each resource. Okay, so we have total 9 for loops. Okay, initially, and after that we have the while loop here. This is the main part. In the while loop we'll just start here, how much time it will run, loop C times, means at maximum it will have 5 iterations. Count is not equal to P, means how many processes are here, that count is kept here. And once we reach in the loop C, for each iteration it will pass by, like first iteration it will pass 5 times for the number of process. It will check if the process has not been satisfied earlier. If it's not, we'll come here and see each resource need is less than the available need. If yes, we'll take it into consideration and do this thing, remove the name from this list and add it to this list, and how much was allocated to him, that will be released and adding up to the available resource. That process is happening here. Okay, after that the name will be written from this list to this list, that I already told, and it will move to the next process. Like that it will iteratively do for each process, and after this has been done, if some is left, again it will come to the while loop and increment the loop count, and again it will pass to these resources. Now in maximum number of iterations, loop C times, which means 5 times it will iterate, and in each time means even after 5 times this was not satisfied, if any of the resources is not taken into consideration, means his need cannot be satisfied. What does that denote is, there is no way to satisfy all the process needs, and there is no safe sequence. And on the other hand, if the thing gets over, means all the processes are taken into consideration by satisfying all their needs with the available resources at that moment of time. At that time we'll output that it's in the safe sequence, and means this is the safe sequence, means safe k will be storing, right? will be removing from this list and storing in this list, right? This list will be printed. Okay, so the final output will be this one, and another one is what were the available number of resources and the need matrix, maximum need and the remaining need. Okay, so that's all from my side for this video, and if you have any doubt you can put it in the my Instagram link is in the description box, you can ask me, and the PDF link I will upload in the description box as well, so you can refer that. And please make sure you subscribe to the channel and support me in making more videos like this, and thank you so much for watching. I'll see you in the next one.